5.3.2 wants us to determine the size of cos 108 in terms of p. So cos 108 can be rewritten as cos of 180 minus 72. Then we can reduce this because we know that this is in the second quadrant. 180 minus is in the second quadrant. So this returns negative cos 72 because cos is negative in the second quadrant. And then 72 is not a value that we have over here, just like 108. But 36 times 2 gives us 72. So we can rewrite cos of 72 as 2 times 36. This allows us to use the compound angle formula for cos, which or the double angle formula, not the compound angle formula, which will return negative 2 cos squared 36 minus 1, and this negative should be outside. Then you can multiply it inside to get negative 2 cos squared 36 plus 1. This then becomes negative 2. Then cos 36 squared. Cos 36, we know it's just p. As you can see from this, cos 36 would be adjacent, which is p over 1. So p is cos 36, and then we square it plus 1. Now answer is negative 2p squared plus 1. There is also another way that you can get this answer. You could use another trig function at this point. In fact, you could use two other trig functions. You could use the one that states, since we have the negative there, we could say this is equal to negative of 1 minus 2 sine square 36, like that. And then this would have become negative 1 plus 2 sine square 36. Then sine 36, we also know what that value is, so we put that in as the root of 1 minus p square, and then we square that, and then this becomes minus 1 plus 2 in brackets 1 minus p square, and then you can multiply the 2 inside. This will be minus 1 plus 2 minus 2p square, and then this simplifies to the same thing, which is minus 2p squared plus 1. The other trig formula that you can use, so besides this, you also have the option of using the one that says this will be cos squared 36 minus sine squared 36. And again, making your substitutions of cos as p, cos 36 is p, square that, minus this is 1 minus p square, square that. You also return the same values from this. The square cancels the square, then we're left with minus p square, and then you have a minus, this minus and that minus becomes a plus, and that would be plus root 1 minus p square in its squares, like that. If you simplify this around, the square cancels that square and we're left with this, and again we get minus 2p square plus 1. So there are quite a number of ways that you could solve this problem by. You could also say from the beginning cos 108 is equal to cos of 2 times 54. Because 54 is an angle that we actually have in our diagram, we could then use the same trig functions, either one of the three again. Because as long as you have cos of a double angle, which is 2x, there are three identities you can use, either 2 cos square x minus 1, or 1 minus 2 sine square x, or lastly cos square x minus sine square x. So you can use either of these identities. Then lastly, you can use cos 108 as being equal to cos of 72 plus 36, and this will sum up to 108. And then you could use your compound angles, which state that cos of a plus b is equal to cos a times cos b minus sine a sine b times sine b, like that. And then you could make your substitutions with a being 72 and b being 36. Then you could still solve a the same way, but this method is not recommended simply because of how long it would be, because you have 72, which is not part of our angles in our triangle, and that would need you to break down 72 using either one of these methods, preferably this 2 times 36, and then you would need to include one of these long proofs in this problem, so this one would not be advised.